Hello everyone. This video is very special for me because it's going to be a lot of fun and it's a solid proof that the moon is a solid sphere illuminated by the sun or partially illuminated by the sun. And as you can see the title here, Mr. Moon, tell me where is the sun? And the moon would say, read my face, elevation angle, azimuth, phase value and orientation. So the beautiful part about this is that I'm almost finished doing this using geometry and math, but it can be done instantly using practical tools like a camera, a tripod, or an equatorial mount. So how do we find the sun using the moon and this information provided by the moon? And we have to know something first about the moon phase. As you can see here, this is the Earth and this is the orbit of the moon. The moon, that's the direction of the sun to the left of the screen, and you can see half of the moon is being lit. But from the Earth perspective, we don't see half the moon being lit. We see something like this. This box or this width here represents the diameter of the moon, and this white portion here represents the part that we see being lit by the sun. So I'll say here this is like 30%. So the moon illumination in that uh, position would be 30%. Now let's go deeper into the moon. So these are the two lines to the sun, and we have here the radius of the moon, and we have here a triangle marked by the percentage of the illumination. So we said this looks like maybe 15% illumination. This 15% is in relation to the whole diameter. But in relation to the radius, it would be radius minus twice the illumination. The relation of this one to this one, you have to multiply this by 2 because you divided the diameter by 2. So anyway, we have an angle here, this angle 2 and this angle 1, and you can see of course that they are equal. We can get this angle 2 from this triangle. This is the radius and this is radius minus illumination, and radius here would be just number 1. I'll use 1 for this equation. So a1 equal a2 equal inverse cosine of 1 minus 0.15 divide 1. So that would be 0.85 divide 1. You would get the angle. So that would be the amount of degrees you'd have to change your view from looking at the moon until you'd be looking at the sun. And the way to do this, of course, you'll have to orient your phone or your camera so that the moon would not be tilted like this. You would tilt your tripod or your base in order to have this lit part to the sides of your frame. Once you've done that, you can rotate the phone or the camera on your tripod, and even better if it's equatorial mount, you can rotate it the amount of degrees you need. But I think you'd have to do some funky setting for the equatorial mount before doing something like this. Um, so this is how to do it practically, and using geometry I've gone almost like 90%. I keep finding things that I ignored here and there, small numbers that I'm missing, and I'm getting a good result until now. Um, and Initially this thing started when I looked into the moon terminator illusion, how the sun would be on the horizon while the moon is high and pointing up. The point is that if you follow the path, this path is the direction of the illuminated part, and it's an arc. When you pan your camera, you don't pan it horizontally. You should pan it into the direction of the illuminated part. So it would go up and it would go down. And I hope someone can do this practical exercise when that condition is present. When the sun is about to set, the moon is high, and the illuminated part is pointing upward. You set your camera, um, you pan your view towards that side with the same amount of degrees calculated upon the moon phase, and you're going to see the sun right there. So that's it. It's very simple. And thank you all for watching.